So the last thing that we want to take a look at tonight is what happens with the switch state. And so starting on page 105 of the handout, here we have the definition of a switch statement. Now, in C++, a switch is basically, how else could you describe a switch statement?
It's like combining a bunch of if-elses.
It's an if-else. What is a switch statement called in other languages? Anybody remember? It's called anybody remember? It's called it's called a case statement. Okay. So as Ian said, basically you can also do it as a bunch of if then else nested if then else statements. So what we're going to do is basically what we do is we're going to set up what's called a jump table. And we're going to take and use, when we look at the assembler, we're going to see where this command .addrss is used. And when you see this, it's always going to be followed by a symbol. And the symbol basically is going to be is going to indicate a memory location to take and in essence jump to or branch to, however you want to think about it. So here on page 106, we see a little C++ program again. So we've got one variable, which is a local variable called guess. It's an integer. We're going to ask the user to pick a number between 0 and 3. So you've got the C out for the prompt, you've got the C in for the guess, and then you have the switch statement. So we're saying switch and use the variable guess. With switch statements, you set up cases. So here we've got 4 cases representing 4 possible input values. So we have case 0, case 1, case 2, and case 3. So depending on the value in guess, which again is going to be 1 to 3, we want to take and just jump directly to the appropriate case statement. So if we input the number 2, we don't want to have to go through figuring out whether we're going to use case 0 or case 1. We just want to take and jump straight to case 2. And all of these cases are basically a cout statement followed by a break. And if you remember way back in the dark ages at the beginning of this class when we took a look at switches, if we didn't have this break here, does anybody other than Ian remember what's going to happen? I know you know. Does anybody remember?
Go through all the cases.
Correct. So if we didn't have that break on case 0, if the person guessed 0, the program would jump to the appropriate location for case 0, execute the commands for case 0, but then it would just continue on. So if we didn't have any breaks on here, if the user inputs 1, we're going to output close, then we're going to output right on, then we're going to take an output to high. So if you remember when we were talking about cases before, we said in certain circumstances we might want to do multiple things based upon what the user inputs. So we might have some fun. We might give the user some, a list of items, and if they select number 2, we want to do something, and then we want to just automatically do whatever is represented by 3 on the menu. So it can come in handy. Even you can use it again. You can use it in program. You can use it with just in your program logic. Because again, you might do some calculations and then you evaluate a value, and you can take and do multiple things depending upon how you have your case statement actually set up. All right, so looking at the assembly language real quick, and the assembly language for this is on page 107. If you flip down, 108 has the bottom of the program, and that's basically just the 5 messages that we're going to use in this program. So it's pick a number, and then the message 0, message 1, message 2, message 3. So looking at here, if you go down and just look at memory location 13, this is where we set up our jump table. And we're using the dot address, and we have the symbol. So when you run this, based upon whatever we have calculated, it's going to jump to the address that's represented by the appropriate case. So if the user inputs a 2, it's going to jump to the memory location represented by case 2, which in this case is memory location 27. So it's going to jump there, and it's going to execute. It's going to say output right on, and then it's going to break to end case, and that's going to take and just output a new one. All right, so Catherine, give me a number between 0 and 3.
2.
2. Good choice. All right, so let's take and run this, okay? Again, no global variables, so nothing is set up. So now we come down here, we allocate guess, that gets put out onto the stack. We do our input, so we get our input, which is 2. And again, I didn't clear memory, so we're going to see some garbage in some of these. All right. So now we've got we got 2 sitting out in guess. So now we're going to load that into the index register. And now, because our case statement, we are in essence using integers, and integers take up 2 bytes. We're going to take and we're going to multiply it by 2. So we do the multiplication. It comes up to be 4. So now we're going to do a break, and we're going to jump to the appropriate spot in memory. So what happens is, so we've got our index register, and it's 4. So what we want to do, what's going to happen here is our jump table starts at memory location 13. So what's going to happen here is the guess JT is a symbol that represents memory location 13. We're going to add 4 to that, which is going to be now going to be 17. So we're going to break to the memory location whose symbol is case 2. Okay. Was that clear? That explanation a little bit clear, a little bit muddy? Everybody get it? Everybody not get it? So now we do the break. So we jump to memory location 27, print out right on. And now we do the break because we don't want to execute anything else. And we just do the out. So I want to run this again because I didn't notice something the first time through. So we take and actually what I'm going to do is I'm going to click memory first. So we run this. Keep yes. So we get the input. So now what I just wanted to see was the program counting here. So I load the index register and multiply it by 2. So my program counter now is 10. Execute it. Okay. So yeah, so that does. All right. So notice that our operand specifier is 13, and 13 does equate to the start of our jump table. So you add in the index register with the operand, and again, that gives us 17. Look at where that symbol points to and jump to. So that's that. Okay. Any questions? Anybody want some extra credit?
Yeah.
Okay. What I want you to do, I want you to take this last program, and I want you to take and I want you to change it so that you take and you input a letter and change the case statement to evaluate the letter. Actually, you know what? No, forget that. The extra credit is, if you want to do this, is do a little research and write me a paragraph on how, and a paragraph is at least 4 sentences put together intelligently, at least 4, talking about how the case statement using letters would work. So how many points should we make it, Jordan? 100?
Yeah.
I second that.
For a stinking paragraph?
Like my
What
lord.
about
I mean,
2
yeah.
paragraphs?
Well,
I'd prepare that.
huh?
What about 2?
2 paragraphs?
One for 100 points.
For 100 points?
A whole essay for 100 points. It won't be any good because I'm not a writer. but-
Okay, well, all right, an essay. So, in order to get the 100 points, you have to write me a 5-page paper, single space, 8 point type.
Yeah, I won't
What's that?
get it. I don't want to get
You don't want the extra credit?
it. Not if that's the deal.
Well, unfortunately for you guys, this is not a republic or actually, this is not a democracy. It's a dictatorship. But not even a dictatorship. So, all right. Write me a paragraph or 2. Just write me a short description of how doing a switch statement with letters, how that would be done. I'll put a form out on. Actually, no. I want you guys to submit this. I'll create something and send an email out about where I want you to put this, and let you guys know. This will be due by class next week, and I mean, if you do a good job on the explanation, okay, you'll get 100. I'll give you 100 points. Deal?
We post this on Blackboard, the actual assignment.
Why?
In case we forget.
In case you forget. Yeah, I'll put it out there.
Thank you.
This is just this is extra credit off the top of my head. So if you really have to put a lot of effort into it, don't worry about it. And I'll look at this too. And if it's too much, I might have to change it. But we'll do an extra credit for you guys. Usually I do a lot of extra credit, but there hasn't seemed to be opportunities in this class. So let me take a look at it. I'll get an announcement out on Blackboard and send all you guys an email detailing the extra credit assignment. Okay? Any questions about the stuff that we've been covering? It's a lot of stuff in 6. A lot of stuff in chapter 6, and it's a lot of good stuff in understanding this. So, by hook or by crook, next week we're going to finish. Next week is week 11, I think it is. We're going to finish up 6. Then we're going to spend probably 2 weeks talking about Chapter 10. And Chapter 10 is a really, at least to me, it's a really interesting chapter. We go down even further and talk about logic gates. And if you want to get a little bit ahead, take a look. There is a program that we're going to be using called Wireshark. So I'm not sure where you get it, but if you Google it, you'll find it. And basically what it's going to allow us to do is to simulate logic gates and see how certain inputs go through the logic gates. So, anything else? Okay. Thank you for at least trying to stay awake in the warm room late at night after a busy day, I'm sure. All right. Have a good week. I will get the extra credit assignment out there. So since we are finishing up Chapter 6 next week, the Chapter 6 assignment is going to be due. So again, start working on that. I'll take and review that too, depending upon what I decide to cover next week.
Is that due next week?
What's that?
Is that due next week?
No, it'll be due in 2 weeks. Or, might extend it out. We'll have to see. Because I think a lot of the stuff that we're going to do with Chapter 10 is, I'm just going to do it in I'll just do it in Wireshark, and so that might, the stuff that we do in class, that might just be the assignment for Chapter 10.
Does that have a different name than
What's that?
Wireshark?
What's that?
Does that have a different name than Wireshark? Is there something else in the material that's got? Because Wireshark is a TCP/IP.
Nah. All right, it might not be Wireshark.
I've used one before. It's called Bios.
That's it. I'm sorry. When one of my master's classes, we used Wireshark and LogicSim, and I got confused about it. But I'll put that out on the. Yeah, I took it off. I'll put that out as an announcement on the bulletin board too. But it's not Wireshark; it's LogicSim. So again, if you want to take a look at it, and that's all I've got. So we don't have anything else. Adios. Stay off of boulders.
Mm-mm.